Welcome and good morning to this co-hosted webinar by LSD, GitLab and Red Hat. It's called Make It So, Managed Automation for Containers with LSDautomate, GitLab and Ansible Tower. We're going to find out how to have frictionless, secure and auditable infrastructure and app deployments. Our hosts today is Julian from LSD, he's a solutioneer. We've got Adrian Waters from GitLab, the Senior Solutions Architect, and Nuno Martens, who's a Senior Channel Solutions Architect at Red Hat. They all know a lot about automation and they can show us today. And their agenda for today is, after I stop yapping, Adrian will take over to show us some of the new features of GitLab. Then we have Nuno, who's going to show us some of the functionality of Ansible Tower. And Julian will walk us through LSDautomate and how it ties together. That's all I have from my side. If you want to check us out after the webinar, please have a look at our all three of our websites. You can contact us from there to try and set up something around managed automation, or if you're just curious about automation in general, please reach out. That's me. Thank you very much. I'm going to hand over to Adrian to show us some of the GitLab stuff.
Okay, good morning, and thank you, Charles. So you've done the intro. I'll just add, I'm the solutions architect at GitLab within the channel team, so I work closely with partners such as LSD across EMEA. So really pleased to be here today. I've got a fairly short slot. There's a lot overall to cover in this webinar. So I'm going to sort of talk about some sort of generic topics around GitLab, particularly focusing on the automation sort of side of things. I think Nuno will then do similar for Ansible, and then Julian is going to glue it all together and give you the real demonstration. So I just thought to start with, I'll just outline what GitLab is today as a product. It's sort of not always known what we do. I want to talk a little bit about GitLab Runners, which is the part of the GitLab product that is responsible for running pipelines and jobs, so very much automation related. I'll do a brief demonstration, and then I'll talk about some other sort of areas of functionality that really can enhance automation if they're done right. And there's some sort of areas of functionality that maybe aren't as widely known within GitLab as sort of other areas. So sort of looking at what GitLab is today, the DevOps environment, over the last few years has developed in various ways, and many customers end up with a plethora of different tools that they're gluing together, they're integrating to provide their overall DevOps toolchain. And that sort of, that process has evolved, and whilst each and every one of the tools might be great, that sort of complexity of integration causes sort of problems and friction that in some ways detract from what you're trying to achieve with DevOps. So complexity, risk, management overhead, and so on. So which part does GitLab play in that? So we're a source code management and a CI tool, aren't we? We have those capabilities, some issue management, some CI, and obviously Git repo management. And that's still what many people understand GitLab to be, whereas in reality, that is where GitLab was, around 10 years ago. And since then, we have developed the product extensively, both in terms of the depth of functionality within those particular areas, but also in the breadth of the software development lifecycle that GitLab supports. So we now sort of have a single application or a platform that encompasses the full software development lifecycle, from initial requirements planning, management, through the CI side of things, up to packaging, artifacts, application security, deploying, the CD side of things, monitoring production, and securing production. So all of that is available within the GitLab product, and that brings a lot of different benefits that are listed below, and it certainly aids automation. Now, that doesn't mean to say that every GitLab customer has to throw all their other tools out of the window. That's just not the case. So we're also very strong in providing integration with specific tools and products if that is what is most appropriate for those specific customers. But overall, the general feedback that we get from our customers is that the more that they adopt of GitLab by reducing other tools, the better results they will get. So that's just a bit of a scene setting to just paint the picture that GitLab is more than an SCM and a CI tool. So I'm now going to look at the life of a GitLab job. So you're probably, if you know GitLab at all, you'll be familiar to a degree with pipelines and jobs. But often people don't really look behind, well, what's actually happening when you run a job or when you run a pipeline. And because it can have a considerable impact on the overall effectiveness of your automation, I thought it's worth spending a few minutes to touch on that. So here's a typical pipeline. It's building some software. It's doing some various tests, some security tests. It's producing in effect, a review environment where changes can be looked at by the developer. Because it's running live, that preview environment, we can also then run dynamic security tests against it, performance security tests, and so on. So just a typical pipeline. And in general, going from left to right, we have stages, and they will run in sequence. And within any one sequence, we can have multiple jobs that run in parallel. And I've highlighted the fact that that's not always the case. Because you can have dependencies. Certain jobs might need something from a previous stage. They may not, in which case they can be triggered earlier to reduce the overall time that the pipeline takes to run. But how do we actually run those jobs? So we have this process called a GitLab runner. So it's a separate piece of software to the GitLab server. And typically in an installation, there will be many runners installed. And they may be, in a data center, they may be running up in the cloud, they may be running on your laptop. And all of those are possible, and all those are possible concurrently. And what a runner does is sits there, polling the GitLab server, saying, hey, I'm available. Have you got anything for me to do? And at some point, when there's an appropriate job, that will get allocated to the particular runner that's been chosen. The runner will then pull down data that it needs. It will then run the job via this thing called an executor, which we'll touch on a bit later. And when that job is finished, it will then upload the results and the artifacts back to the server, so they're sort of available going forward. So that's a simplified view of what goes on. So a key aspect of making sure your automation is effective is that jobs get picked up as soon as possible. And allocated to runners. Another thing just worth mentioning is this word here, the runner pulls a GitLab server. And so from a security perspective, that's important. It's not, the server doesn't need to reach out. It's been contacted from the outside. So it's much easier to firewall around the server itself. And then the other aspects that are really important is what type of runners they're, sometimes customers think a runner is a runner, and it's true to an extent, but there are various different types, and they can be used for different purposes and to different effects. So we can have shared runners that typically are set up by the central server GitLab admin, and they're available for anybody to use for any project. And so, for example, on our SaaS platform, gitlab.com, we provide a whole host of shared runners that any of our SaaS customers can make use of in their jobs, in their pipelines. And then on the right-hand side, we have what we call specific runners that are created at group and project levels that are then only available to jobs within those groups and projects. So you can create more custom, a custom runner fleet that is being used by just your project or your group of projects. So you can scale them accordingly to make sure you have sufficient demand for that. And again, talking about our SaaS platform, for our enterprise customers that go onto our SaaS platform, they typically want to have their own runners. They may use shared runners, our shared runners for some generic jobs, but often prefer to have their own runners under their control within their network that can run their jobs that are hosted on our SaaS platform. And then this tagged and untagged, this really says what jobs a particular runner can handle. And the example here is on the left, we've got a runner that is set up for Windows type builds. On the right, a more generic, maybe sort of Linux type work. So if you were to throw the Windows pipeline at a runner in a Linux environment, it's not going to work too well. And then the final one are protected versus non-protected. So non-protected runners can run any job from anywhere, any branch, and so on. Whereas protected runners will only run jobs on protected branches or protected tags. And so from a security perspective, for example, if you've got a runner that is going to deploy something into production, and it has access to deployment keys, then you can put those, define those runners as protected, and that will limit then the scope of where those deployment keys can be seen. And so using that combination of those three previous types, if you architect your infrastructure properly, you can sort of generate an effective fleet of runners to maximize the automation of your jobs. And then just going back briefly to the executors, I said the runners at the end of the day use an executor to actually run the job, and you can have different types of executors. These are the most common, just the shell running bash commands inside Docker or Docker Machine or Kubernetes. And it's interesting with these two, their scaling capabilities, auto scaling up and so on. And that is important. If you've got a pipeline, you don't want it to be sitting there waiting to run just because there isn't a runner or an executor available. And so getting that infrastructure correct with appropriate scalability will really help your automation. So I'll quickly flip now to a bit of a demonstration. I have this is running on our SaaS platform, a simple project. It's a node project, and it generates a simple web page. And what I wanted to do was really give you a view within this project of the sort of the end-to-end approach. I don't have time to run through it all, so a lot will be showing things that have run before. So this is the Git repo. It's interesting if you look down here and compare this back to the slide I showed of all the different stages of the DevOps lifecycle that GitLab supports. Then you can see some of those aspects. So issue management, Kanban style boards, etc. Requirements planning, security, application security monitoring, deployment environments, which I'll show a bit more of, monitoring those deployment environments, integration with things like Kubernetes, analytics, container registries, and so on. So all of that is there. I won't be touching all of that today, just because of time. But for this particular project, I do have it linked to Kubernetes cluster. You can see I have a number of clusters set up here. They all happen to be running on GCP. Some are at the group level, but I got one assigned or linked directly to this project. So that will then become the default cluster that this project uses. And if I look at the different environments that I have for this project, we can see I've got a production environment, I've got a staging environment, and I've also got some of these review environments, which is like temporary work in progress instances of the application. And we can see from here that I've got 5 pods in this, my deployment infrastructure, and it's currently got a canary deployment. That's the little icons there. And from here, I can actually go off and look at the end result. This is the deployed application within that Kubernetes environment. So how did it get there? Well, everything really. There always has to be a reason for doing something. An issue, a feature request, a bug, whatever it may be. So I'll just show this, which is sort of already got a number of issues in there. And one of the changes that's a bit of work in progress at the moment is a change to change the background image of the display. So if I drill into that issue, then we can see, oh, okay, the requirement has been logged in there. Change the background to use this image. I can see that there's already work going on this. There's a merge request. I think, again, Julian will probably cover in a bit more detail later. So I'll go and have a look what's been done. I can see that there are various code changes already applied, and it looks as if, yeah, we've changed the background image. For now, I'll assume it's the correct one. But there's also some other changes here which look a bit strange. There's a new file being added that looks very much like a private key, and there's also oh dear, somebody's put a password into my source. Not necessarily the best of things to do, but let's have a look at the effects of that. So I can see that a pipeline is run, and I can see the results of that by looking at the review app, and I can see, oh, the background has changed. If I look at the previous, got that, I've now got the changed image. So that's good. That's looking positive. But if I look further down in this merge request, I can see some not so good things. I've got some security scanning gone on, and it's identified some problems, which is to be expected because I put a hard-coded password. So it's picked that up automatically. It's found some dependency vulnerabilities. It's actually detected that I've put a private key into the repository. So it's all well and good identifying those issues. We also want to then make it easy for a developer to resolve them. So one of the premises of this approach is that if a developer can sort out a security issue quickly there and then great. It's out of the way, it's sorted, it doesn't get propagated anywhere else. So as a developer, with an ego, I would like to now fix this before anybody else sees my silly mistake. But if I'm not comfortable with doing that, then there are various actions I can take. I could create an issue, for example, that will be pre-populated. It will tell me exactly the line of code that the vulnerability was created in, and this could get picked up by security team, for example, to process it with their sort of greater expertise. And to that end, there are various different reports and dashboards, both at a project and a higher level, that can be used by a security team to get that overall view of the security posture of your applications. Now, if I look at, we saw that pipeline and think, well, where did that pipeline come from? I've got another pipeline here. This time, this is on a master branch rather than on the feature branch. But we can see it's doing similar. It's building software. It's running various tests. It's creating the preview environment. It's then deploying into staging, and it's then deploying into production. We're also running some performance tests against that production environment. We can see here that we've done an incremental rollout, so we've only deployed into 50% of the estate at the moment. Now, normally within GitLab, we define a pipeline by creating a YAML configuration file, but there isn't one for this project. And if I go through the process of manually creating a pipeline, I'll choose Bash as a template just because it's easy to see, and we can see, this is a typical flow. I've got a stage that does a build, got some stage that does some testing in parallel, and then I've got a deployment stage. And within here, I can just put whatever commands I like. So, this would be an opportunity if we wanted to use Ansible to do the deployment to production. I could put sort of the appropriate Ansible commands playbooks in here to do so. In this case, I'm using AutoDevOps, which is our way of automatically creating a best practice pipeline from build through to production. And it's fairly simple. If we get past all the fluff at the top, we can see there are a list of different sort of jobs. A YAML file for doing the build, one for doing test, one for checking code quality, one for deploying. So if you want to use AutoDevOps to automatically do that build, run all the security scans and so on, but then replace the deployment part with, say, using Ansible, then you absolutely can do that. You just need to replace or extend this job in some way to add that sort of extra functionality. Okay, I'm just conscious of time, so I'm going to flip back to the deck and just talk about these a few little areas of functionality that really can help and assist with your development automation. So, key thing for DevOps is you want to develop and release quickly, but conversely, excuse me, you want to keep your main or your master branch green. You don't want to break the build, and this is sort of a sample flow that the GitLab sort of promote and recommend. And this part is really the developer. They're doing their work, they're making changes, they're running all the tests, they're getting approvals. When they're happy, they're going to merge that back to the parent branch. And that's great. If you're working in a low velocity development environment, a few developers, me doing a demo, I create my merge request, I make my changes, and I merge it back. And 10 minutes later, somebody else might do the same. So it's great. And if when this second merge request is being actioned, it finds that well, there's something changed now that impacts this, that developer can just rebase and then do the merge. There's no real problem around that. However, if you've got many developers, lots of MRs going on at the same time, then you can end up with this situation where the user for the second merge request can't really proceed until the merge request from the first user is finished. And depending on what their pipeline is doing, that might be 5 minutes, 10 minutes, 15 minutes, or more. So you end up with this queuing approach where developers can't really proceed and confirm what they've done is correct, and then you get into the problems of context switching and so on, which reduces effectiveness. So what merge train functionality does is takes that away from the developer, and it automatically builds up a train of merge requests to be applied to the master branch, and it will incrementally run the pipelines with what the combinations of changes would give without actually necessarily applying them to the master branch. And so in this case, before merge request 1 is finished, it will combine that with, or the results of merge request 1 with merge request 2 and try and build that. It will then do the same with merge 3 and merge request 4. So they could all be running in parallel at the same time, but it will apply them to the master branch only when they've completed successfully. So in this case, if merge request 3 causes a problem, okay, no problem. We'll just take that out of the train for now and proceed with merge request 1, 2, and 4. The developer can then go away and sort out merge request 3. It's only affected that one merge request, that one developer, rather than everybody. So it sort of removes that bottleneck of the train. Feature flag, again, sometimes it's a feature we've had for a little while, but people don't always know about it. It's generally accepted that this progressive delivery is an effective and best practice for deploying. So what we can do is define a feature flag. We can add certain strategies. In this case, we've said, well, we want to roll this capability out to 5% of the production environment, but 100% of users for the staging environment. So we can configure that feature flag within our code. We can then put the necessary conditions to say, if the feature flag is enabled, then do this. If it's not enabled, do that. Fairly simple to include into your code. And then you can dynamically toggle the feature flag on and off at will, whilst the application is running without having to do any new deployment, and you will change that sort of live experience. And then the final one for me is about compliance and compliance pipelines. There are a lot of areas within GitLab from a compliance perspective, an audit perspective that are really appropriate for sort of enterprises using the product at any degree of scale. And one of these is the compliance pipelines. So for any project, you can tag it as belonging to a particular framework. We use framework labels. There's some standard ones, and you can create your own custom labels. And the effect of those is that it allows you to reduce the scope of settings that may be appropriate globally, but aren't for those individual projects. So you can tighten up, how that project should operate, how it should be developed. And one of the aspects there is that you can create a pipeline or a job that is defined and stored outside of the specific project itself, but will always run as part of the pipeline for that project. So the developers who are working on a specific project can create their own pipeline, to do what they need to do. But on top of that, it will always run the jobs that are mandated as part of that particular compliancy framework. So it might be to run a particular set of security tests, or to ensure that specific logs are created and compliance requirements are met. Okay, I think we're going to keep questions until the end. So with that, I will hand you over to Nuno. Welcome questions at the end of the session.
Good morning, guys. So as we're going to see today, we're going to see some Ansible, we're going to see some GitLab, which the guys at LSD are going to show us. But I just want to take you through some of the changes from an Ansible perspective from Red Hat. So before we dive into this, there's some major changes which are taking place on the platform. And, these things are all about, being able to deliver automation sooner, quicker, make your automation a little bit more agile. But I think we should also understand really what Ansible's all about, right? So although we're going to see Ansible working with GitLab here today, and we're going to see how it assists with our pipelines, with CI/CD, all of these types of things. Fundamentally, Ansible is an automation platform which allows you to pretty much automate most things, as well as to put tools together in the form of being a glue, right? So it creates glue, and it basically is the glue between all your different tool sets. So if we have a look now at the changes, and these changes would be announced at Ansible Fest this year, there's a few fundamental changes in terms of how things are working. So firstly, we are no longer going to be having Ansible Tower and Ansible Engine. This means that these products are obviously going to be changing. You'll still have things like the GUI that we used to, but we have some fundamental changes underneath the hood here. So from the changes in terms of Ansible Engine and Tower, these are getting replaced. So Ansible Tower is getting replaced with Automation Controller, and the Ansible Engine is now going to be replaced with something called Execution Environments. So I'll dive a little bit deep into the execution environments and kind of what the idea is. But these are the two fundamental changes that we're seeing. Now, apart from this, we also have two new tools which are coming, which is Ansible Builder and Ansible Navigator. And then lastly, we have a private automation hub. So I'll dive into how all of this is going to work, and how the typical workflows that you're going to be seeing, and how Ansible is now going to operate, basically. So from the automation controller, architecture is pretty much the same in terms of what you guys are used to. We have a GUI in there, we have API, we have role-based access, we still have workflows, we have all of these things that typically you would have seen in Tower. And remember, the whole point of Tower really is to bring scale to Ansible. So a lot of people are still using Ansible from an Ansible Engine perspective from CLI, but this doesn't scale well. So that has always been the focus around Tower. So now with controller, we still have that, but now you can see there's a little bit of a fundamental change in the sense that we're not dealing with Ansible on the control node. We're actually dealing with individual execution environments. So what is the execution environment? So this is what replaces Engine. And basically what it is it's containerized Ansible. So you'd be able to build a container with a standard UBI image. Inside of this container, you would allocate your collections that you would need. Obviously, from a automation platform from Red Hat, we do have our cloud services at cloud.redhat.com, and this is where we get our certified collections, right? So certified collections from different vendors and different tool sets, different roles, modules, etc. So you're able to go and build a container with a base version of Ansible in there. So you'd have Ansible core running, and you would then go and select your different collections that you'd want as part of that container, and any additional Python libraries or anything like that you would need. And what this builds is that execution environment. So what is really the idea around all of this? Typically what would happen in a Tower situation You would have Tower with multiple collections installed, different use cases all using Tower, and this can get a little bit messy. So working this way with execution environment, it means that we can now go and build standardized cloud native execution environments for specific tasks. So if you have, for example, network automation, we would go and build an execution environment with all the collections we needed, all the libraries we needed, all those different tool sets specifically around network automation. Obviously, because it's a container, this also means it's a bit flexible, right? So if you have other automation platforms or you have other clusters in place, this execution environment can then be reused, which is great. So this is really the focus. It means that we can actually bring all of these, have specific execution environments for specific types of automation that is going to take place. Now, if we have a look at how it would all work, basically, you would have a user. The user goes and he has to build this environment, right? So this is where the new tools come in. So you would go and you'd create this. You'd create a requirements file for the libraries, a requirements file for the collections, and if you have any requirements from the container itself, maybe you have some OS-based stuff that you'd need inside that container, you'd build these files, you'd push it through to Ansible build, and ultimately this would build your execution environment. Now with this execution environment, we still want to be able to test before we actually use it, and this is where something like Ansible Navigator comes through. So Ansible Navigator allows us to actually test plays inside of this execution environment, make sure that it's all working before we move on. So how do we work with all of this together? Effectively, we have a developer. He uses Ansible Builder, he builds his execution environment, and Navigator is there for testing. All right. This execution environment can also then be stored in a registry so that we can always, pull this container image. So the full workflow would look something like this. So I am a developer. Again, I go through the process. I have to go and build this execution environment. I take my collections, I take my Python libraries, etc., and bundle that with Ansible Core. I build my execution environment and I publish it to my private automation hub. So private automation hub is basically becoming our registry for this, and this will contain this as well as other things which we'll dive into a little bit later. But from this private automation hub, we can now go and pool these execution environments to our different clusters, and ultimately then use these different execution environments wherever they need it. So if we have a look at the architecture, if we have a look at all the components that we have in here, we have the content areas. So where is Ansible really working in terms of infrastructure, cloud, network security? We have the command line component. We then still have the cloud services which are part of this. So if you remember in the previous version of automation platform, what do we have? We have the CLI component. We used to have Tower, and then we would have cloud services. So we still have these cloud services. These are the things like the automation services catalog, where we can go and pre-build service catalogs and basically have users or business users able to order automation as they need it. We have the insights component, which is all the analytics, and we also have an automation hub where we have all the certified content that comes from our partners from a automation perspective. Now from our on-premise, we will then have the automation controller, and obviously we have a bit of a private automation hub component there as well. So we are able to store that content, the remote content, the different repros, etc., on that private hub, and also keep our execution environment images there so that we can use it with our deployments. So from the automation hub architecture, this is going to basically provide us with the place that we would store our execution environments that we can pull out from a registry perspective, but at the same time it allows us to pull in things like the certified collections from Automation Hub. It allows us to pull community content. So we can pull content from Galaxy, and we can also have customized repositories. So perhaps we might have some repositories sitting in GitHub or something like that, or GitLab, and we can pull that into Automation Hub. Okay, so Automation Hub basically becomes our first stop for resources in terms of what we would need to carry on with our automation. Now, From the collections perspective, we can still grab these collections through things like requirement files or command line, but now we can also pull this through the controller itself. So the automation controller will then talk to our hub and basically pull the relevant information that we need, right? So this is a really great way to work, especially when we want to centralize the resources in terms of what we're trying to roll out from an automation perspective. So here we go. This is basically our development cycle. This is how it will now go and work. Okay, so creators can go and create a collection. They can build a collection with the dependencies in terms of Ansible versions, etc., libraries, and they can just go and run Ansible Builder to build that execution environment. Okay, inside of that execution environment, we have these components again. We have the cores, we have the dependents, we have everything we need. And this would ultimately then get pushed through to Private Automation Hub. So we'll have that single centralized area where we would be able to maintain and keep these execution environments. Now, from the testing, basically, this makes a bit of a more cohesive, more consistent, predictable type of developer experience, right? So if we're using things like an automation navigator or Ansible Navigator, this means that we can go and we can choose which platform to run things on. It gives us the ability to leverage CLI knowledge and introduces enhancements, right? So the whole enhancements around the fact that we're using containerization in this. So an example would be that we could go and build a execution environment. Now I want to quickly test it. We could run Ansible Navigator, and Ansible Navigator would then go and test the automation inside of that execution environment before we push that out to our private repository. So outside of these fundamental changes, I think it's key to understand that we still have the core benefits of what Tower used to give us, right? So from Automation Controller, we're still getting things like credential management. We still have centralized login. We still have audit trails. We have APIs, webhooks, and we obviously have workflows. So I'll dive a little bit deeper into these for anyone who's not familiar with them, but we still have all of these key concepts which allow us to bring automation at an enterprise level. So firstly, dashboards, the controller dashboards are still there. So we can still see what's going on in our cluster. We can still get the benefit of having a pane of glass view over our environment, how many hosts we have, if we have failures, how many templates are being run, etc. But at the same time, this also plugs into the cloud offering. So, the cloud services that we get from cloud.redhat.com, we still have this, and we're still getting things from automation analytics. They're just now called insights, right? So we could log into there. We would be able to then see all the analytics around our automation platforms themselves, which jobs are running, which jobs have failed, which organizations or which teams are running the most automation. All of these things are still there. Workflows are still there. Obviously, workflows are critical. And for those of you who don't know, what is the workflow? Well, the workflow is basically us trying to remove kind of like a single automation task, one by one type of scenario. So with a workflow, we can actually go and build a logical diagram or a logical flow of automation that allows you to have that end-to-end. You can go and graphically build it. You can build these different components. You can build automation that is supposed to be running on success. You can indicate that it needs to run on failure. So this also helps with things like rollbacks, and it's actually a really great tool to plot out the automation. So this is still there. It's still there with surveys and all of these features that we are quite familiar with. Now the APIs, again, we have APIs still built into controller. So, if we're working with other tools, for example, like in ITSM, maybe you want to work with ServiceNow, etc., which benefits largely from using an API. We can have these API calls going back to controller and obviously triggering the templates or the automation that we need. This is also a really great tool for developers who don't necessarily want to interact with the controller or anything like that. They could just go and trigger the specific API call, and then obviously the controller will trigger all of the automation associated to that call. Alright, so if we're looking at the automation lifecycle and how we're going to consume it, this is basically what we're looking at. This is the overview. We have our users, we have our domain experts, and we have our platform. So from the platform, we have our domains in terms of what Ansible's doing. We have the integration layer. This is around Automation Hub. So, the different third-party tool sets, the third-party collections, etc. It's all part of the Automation Hub. And then lastly, from an execution layer, we have Automation Controller. And we also have a services catalog, which sits on the cloud side. So you can go and trigger automation through Controller, or you could be triggering automation through service catalog on cloud.redhat.com. So this is the overview really in terms of what we're still getting and what we have from this platform. So there's a bigger picture here. We can see what it looks like in action. So we have our users, and our users are interacting with multiple methods through to the whole control plane, right? So users could be working from the web UI, they could be going through the API, they could be triggering webhooks, and all of this gets driven through to controller, and ultimately controller will trigger the automation in the relevant execution environments. So depending on which execution environment is tied into your templates or to your playbooks, it will obviously control all of that, and this is how automation will basically flow. So this is just an update, basically on the way forward. So I really hope that you enjoyed this. I hope that you can see the changes and they make sense to you. I'm going to hand over back to the team so that you can see a little bit of Ansible and GitLab in action. Thanks, guys.
Jules, you can start your bit on LSDautomate if you're ready.
Yeah, happy. Okay, good. I'm going to quickly run through really quick. So I have quite a lot of moving pieces to this demo. I'm going to run through a little bit of context around what LSDautomate is and how the likes of GitLab and Ansible Tower fit in and integrates. And we're going to be showing some of that pattern, amongst other things. But at a very high level, LSDautomate is integrated Kubernetes DevOps awesomeness. It's an ecosystem of tooling that we build, support, maintain, and integrate. That's really supposed to, accelerate SDLC automation and more than anything, make the developer experience as smooth and as pleasant as possible. We endeavor to just kind of make sure that the machinery underneath, your IDE, once the commit has gone off to GitLab in our case, things run smoothly, and in the event of any issues, of course, LSD is available to dive in and support and look into things. Another, I think, kind of key piece to LSDautomate is that it's deployed Kubernetes native. So every single tool within the LSDautomate ecosystem deploys as a container running in Kubernetes. Obviously, some benefit there in terms of scaling and self-healing, etc. But I think the key benefit really is that it's agnostic of where it runs. So you can run in your data center, you can run your preferred hyperscaler, and of course, that also means a lot of portability. Everyone's kind of concerned around things like cloud lock-in. Just to kind of run through at a very high level, so you're going to be seeing, I guess, 2 of the 6 today, and some of the integration between GitLab and Tower, but we're also kind of delving quite heavily into the GitOps side of things, some Kubernetes CI, and then I think the thing we're most excited about is Ahoy, which is our own in-house developed Kubernetes native release management tool for specifically around microservices and reasoning around versioning of microservices and the services within them, which is kind of why it was built out. So before we kick off the demo, just a little bit of context as to what you're going to see. We're going to start out in GitLab. We're going to build a microservice as part of a kind of greater suite of services. All our builds run in Kubernetes using the Kubernetes executor, so the Kubernetes runner. When we create a merge request in this instance, it's going to result in the creation of a review environment. So GitLab has this notion of review environments, as Adrian was alluding to earlier, and that's where you can kind of UAT, QA, or do any kind of functional test automation that you might want. We're going to actually kick off a performance test against our review environment of the service that we pick on. And then once we are complete with our review and the merge is approved, we will collapse that review environment completely. So the review environment is really going to be a separate namespace that gets created, an ephemeral place where our new build artifact can be tested. On the Ansible Tower side, Ansible Tower in this instance is pretty much facilitating and orchestrating all of the deployment activities as well as the undeployment as such. So creation of review environment, removal of review environment, deployments of new artifacts to our dev, staging, and production based on certain rules that we've got in place. Towards this end, we're actually using a container instance. So we've integrated Ansible Tower with our demo Kubernetes environments, and it actually spins up a pod when we execute Ansible jobs. And we're actually using a custom Ansible runner base image that's pre-installed all of the different modules that we need for things like Kubernetes and various other dependencies that Ansible has to talk to and integrate natively with things like Kubernetes. So it kind of really reduces the time to live to get up and running quickly. And then, of course, we're also leveraging Tower for the things that are, it's very good at, such as making sure environments are managed. We've got inventory represented, inventory management, different job templates with scope tokens, for example, and then using Ansible Vault for protecting credentials. Okay, cool. So that's kind of the context. I'm going to kick things off with just a bit of an overview as to some of the pieces, and I'm going to run this fairly quickly, just so we can also give Nuno some time towards the end there. So what you're looking at is our demo GitLab environments, and you're looking at a subsection of the LSDautomate scaffold. So we, have these customized base images. A lot of customers generally will run into issues. They go down the line of incorporating container native CI/CD with their own CA certs, their own proxies. So we're able to pre-instrument all of those with our own custom base images, and then of course update them and ensure that they are maintained. We also have a number of scaffolds. The scaffolds are effectively inclusions that we can wrap in with, for certain types of builds or deployments, and that's a growing ecosystem as well. So you will see some of the scaffolds for inclusion as part of the demo. So the service I'm going to pick on for this demo is our LSD widget service, which consists of 3 microservices, really: a pricing, supplier, and product. These are all fast API little Python apps, just kind of illustrative. And the one that I think we're going to pick on for our purposes is the product service. I'm just going to quickly give a bit of an overview on how Ansible Tower is set up. So I'm just going to clock in here. So it just needs to refresh. So what we've got, it's slowly refreshing Ansible Tower. There we go. So we've got a number of job templates, which are used to both deploy and remove our microservices to our demo Kubernetes environments. And just to kind of recap on what the container instance group looks like. So in a very similar way to GitLab runners, where your builds run, your CI jobs run as containers, in our case it's pods in Kubernetes, you can leverage container groups to achieve much the same pattern within Ansible Tower. And we actually use GitLab CI to build us a custom base image that Ansible Tower will use when invoking a job template. Job template execution actually occurs as part of our GitLab CI pipelines. So we've got GitLab CI jobs calling out to specific Ansible job templates. So it's quite a nice pattern where we have this almost ephemeral, sort of like a Lambda for CI, where we run a build, a pod gets created, it invokes deployments, Ansible Tower invokes a pod, and of course everything is spun down once those jobs are completed. Alrighty, let's kind of go into the demo itself. So this is my LSD widgets product service. It's just a fairly simple fast API application. I like to create these widgets because I get to come up with ridiculous product names. That's really why I do this. So what we're going to run through is a merge request, which will invoke a new pipeline, a detached pipeline that's only going to run for the merge request. And essentially, that's a way to validate that the code going into a long-living branch is sound, is buildable, the tests run, etc. Part of that merge request, we've got the option to kick off a performance test, which will run just to illustrate that, how you can achieve these patterns. Behind it all, Ansible Tower, being called by GitLab, will create us a review environment. and that review environment will have its own namespace with the code checked out of our merge request branch. Now, a few of the things that I do want to quickly show off before we get into the nuts and bolts is we've got consistent pipelines that are that we're used to build across all our microservices in this instance. And we've got a developer named Bob who's just built a feature to update our base image. And that's linked to an issue. So issues are obviously ways of making sure you're kind of tracking things as a developer. And one of the nice things with using the integrated issue check in GitLab is you can link MRs and commits to your issues. So you can have a nice, easy way of commuting issues through their life cycle and ultimately closing them on a successful merge or build, for example. Quickly run through what the pipeline looks like, and a bit confusing because we are using some of the security primitives inside of GitLab to do static analysis, container scanning, and so you see quite a lot of, let's say, superfluous stages here. And this is through template inclusions. A high-level view of what that looks like. This is our GitLab CI pipeline. We're including some of our own scaffolds just to aid simple, container builds as well as simple container deploys via Ansible Tower. So that's all built out as a scaffold. We've got some workflow rules which define when pipelines should be executed under what's kind of situations or contexts. And for us, we build if there's a merge or a merge request, if there's a commit to a branch, or if there's a tag that's been created that comports to semantic versioning with a V in front of it. So we kind of use that fairly consistently. What we've done in the past for customers, LSDautomate customers, is this is all very adaptable, and not every team wants to be dictated to in terms of how they do branching and how they want to run builds. So I guess what I'm trying to imply is that a lot of this is obviously subject to change and quite adaptable and modifiable. We're still able to leverage some of the acceleration we get from the scaffold. So we're just running our builds, we're running a simple single unit test, and then we're going to do a container build using our container scaffold and a deploy using our Ansible Tower deploy scaffold. So fairly straightforward there. I am going to be driving some of this from the console just purely because there's quite a lot that'll happen in short order. And so I guess the first thing just to validate is we've got 3 namespaces that are housing our LSD widgets microservices at dev, stage, and prod. And if we just have a look at any of them, we should see we've got those 3 services running: pricing, product, and supplier. When we kick off our performance tests, we're going to see lots of new products being created, prices being created, suppliers being added. And what this actually will do is it'll invoke the performance test against the review app that's being built, but include the staging environment because we want to actually test that everything runs and is sound from a staging perspective onwards. So that's the aim of this demo. And the other thing we'll see is a review environment being created. So I showed you the 3 namespaces running out different tiers. We'll have a temporary review environment that upon successful completion of a merge will actually be removed. And quite a nice pattern and a nice easy way to run your testing without consuming static resources permanently. So I'm going to be wearing 2 hats. The one hat that I'm putting on now is Bob, because we've applied some rules that prevents the same developer, for example, from approving their own merge request. We've also put in some synthetic rules around what's permitted from a vulnerability scanning perspective. That's not going to run. Our feature branch is just completed. From a feature branch perspective, we're only going to do the bare minimum necessary to prove that our build passes, which it did, and that our tests run. And these are some of the built-in, very easy to get up and running with GitLab, security primitives for static analysis and dependency scanning. And of course, as Adrian alluded to, we can actually go and introspect any of the security vulnerabilities found within our this repository, from a container vulnerability perspective down to a dependency scanning perspective. So are we installing Python dependencies with known vulnerabilities? And synthetically, that's what we're going to remediate now. And most of these high ones are coming off the container security side. So I'm going to open this merge request as Bob. I've assigned it to myself, and I've given it some labels. And I've told GitLab to delete the source branch, so delete this feature branch where we're updating our base image, which includes a new AR HTTP client. Sorry, I just want to actually switch this around to the developer branch. So I just caught that now. Cool. We can't actually merge directly into the main branch. I'm going to assign it to myself, and I'm going to ask myself as other Julian to approve it, and I'm just going to say that's a work in progress label. Cool. Now, what that's going to do is actually create a slurry of notifications to me, both as Bob and as Julian. And this is going to kick off a GitLab pipeline on the back, in the background. It will be a detached pipeline, which means that because it's running off of a merge request, you'll see there's a separate kind of temporary or ephemeral branch that gets created that's going to run through our stages. Just to show you, I'm a big fan of having asynchronous comms, so we can see a whole bunch of notifications coming through saying that there's a merge request that's been opened. You might want to go and look at it and approve it, and of course, I could quickly go and click, and it would take me directly to the merge request where I could merge it. If we kind of just have a look-see at what's happening here, we're running our test stages, and then we're going to build a specific type of container. So our container scaffold builds us an OCI compliant image, and this will be a kind of temporary image only used as part of our review environment deploy. Once we get to the deploy stage, we'll see a job being fired off from one of our job templates. We've got 3 job templates pre-set up, and the product service deployment will be invoked. So we can actually just wait for GitLab to call out to Ansible. I think one of the neater things with this pattern is we're actually passing a whole bunch of job-specific metadata through to Ansible Tower at deployment time. And this is to be able to apply annotations to our various resources, denoting things like the commit shard, the committer, and some of the things that Ansible or that GitLab actually needs to be able to reference a environment once a pod has been deployed. So this is going to be building our container image. We use Kaneko, nice and headless and super simple to reason about. No need to have any kind of Docker socket. And this job will now be invoking our deployment via Ansible Tower. We actually use our Tower client base image, which has a specific OAuth token that's allowed to execute our deployment job. So I'm just going to close that. And we should see a new job being invoked. So this is our Tower client calling out to Tower and saying, "Hey, we've got a deployment running." And if we go and do a little bit of inspection on the job itself, we'll see that there's a whole bunch of things that are relevant to this specific deployment. We've also got Tower itself telling us, "Hey, a deployment has just been kicked off." So be aware. If we just have a look at what's happening in our namespace, you can actually see that Ansible Tower has invoked a pod in which this entire playbook is being executed. So it's got all of the tooling and dependencies necessary to run the whole deployment playbook, which is using the core Kubernetes module to talk to Kubernetes and talk to our cluster. We actually get a little bit of output directly from Tower telling us what's happening, and we can see that a deployment has just been completed. It took 47 seconds. If we jump over to Tower, we should see that's much the same. It's reflected as completed. The logs are quite involved, so we need to go through all of them. So that's great. We've got a new environment now that's been deployed. Because this is a merge request, it's created this independent review environment. And if we go and have a look at the namespaces, as I was showing before, we've now got a temporary and separate namespace, which has the actual merge request ID in its name. So this is a temporary namespace. And we can actually just have a look, see at what's been deployed there, we should see our product service, so our latest and greatest. And if we were to just have a quick introspection on the product service, we'll see that it's been annotated as part of the tower deployment with all the relevant details. So if we ever wanted to, track back to the commit that actually built this container image with this version of the product service in, we could actually just go to GitLab, look at commit history, find our SHA, and then we can actually go and do whatever kind of introspection we need. And of course, we're deploying this as a kind of temporary image that will be removed. So now we're in a position where we've got a build, but as part of our standard, we need to kick off the performance testing before we're able to continue and complete the merge. So Bob, as the ever-patient developer, is waiting for the ever-lazy Julian to complete this merge request. And me as Bob can't actually go and close it. It's now at the behest of the other guy who is a maintainer to run it through its paces. And of course, this we've said is manual, but this probably would be automated in real life. You want to kind of get out of your own way and not have lots of manual slow steps. But I do want to just be able to kind of illustrate a few of these things, and hence why it's on manual. What we should actually see is a review environment, and we can actually jump over to its ingress. Well, let's just go to docs, and we can actually see, okay, so this looks much the same. I've got a health endpoint, of course, and we should have pretty much nothing left here or nothing new added yet until we run performance. So what I'm going to do is I'm going to say, cool, it looks like it's up, kick off our performance stage. And if we just watch our logs now, we should, in short order, start to see a whole bunch of requests. We only run code for 10 seconds because it costs money. And here we can see that our load generator is actually creating products, deleting products. If you look at our staging logs, we should see much the same. So we run review against our staging environment, and it looks like everything is computing successfully. And we should see similarly in our outputs. So about 10 seconds elapsed, not too bad. Happy to approve. Now, upon approval, what will happen is GitLab will actually call out again to Ansible Tower, and it will invoke another deployment, except it's going to remove our review environment completely. But at the same time, now we're merging it to develop, so that should invoke a new deployment to our develop namespace. So I'm going to approve this. And that will result in Bob being notified that just have a look here, that his MR has been approved, and I'm going to merge, and I'm going to remove feature branch. We don't need to have all sorts of cluttered branches happening. So if we jump back over to our pipeline, of course, getting lots of telemetry about this, we'll see that the stop stage is now being automatically executed, and we should see another job in short order coming up to both remove our review environment as well as deploy our new develop product service. We've taken our new base image into the develop stage, and of course, a subsequent MR would ultimately get this into staging, and if we tag it, we could cut a release, and we'd be running on the latest AI or HTTP clients with some confidence. So just waiting for the removal to kick off. Lots of notifications, which is potentially a bad or a good thing. Yeah, we can see that this is the MR review stage, and noticeably, I mean, I could have cleaned up the notifications a bit, but simply just telling Tower, hey, set the state to absent for our LSD review namespace actually runs in the same playbook, just setting a state flag. Obviously not something you want to do without some oversight, purely because you don't want to accidentally lose something else. and we'll see that this will disappear in fairly short order, and I won't be able to execute anything. No, it's busy going down. So here we can see our environment's been removed, and GitLab should reflect the same, complete, wonderful. And the last stage is to complete a deployment of our new developed environment, which is also invoked by Ansible Tower.
Thank you very much for spending your time with us. From LSD, Red Hat, and GitLab, we appreciate it. We know that screen time is precious.
Thanks, bye.
Thanks, guys. That's all. Ciao.